Hey folks, welcome to another episode of the AppSec Insiders Podcast. My name is Jared Mate, and I'm joined by Farshad Abbasi, the founder of the founder and chief security officer of Ford Security. Say hi.
Hello.
Hello. I'm also joined with Iman.
Hi,
Iman
folks.
Sharfaldin. He'll introduce himself. Go ahead.
Hi, folks. Application security lead at Ford Security, and thank you for having me.
He sure is. And Jordan Sherman.
Hi there. I'm a senior AppSec consultant at Ford Security. Happy to be here.
And so am I. And I'm also glad to be here. And for those who are new to the show, to the AppSec Insiders, it's a show where we discuss the latest trends, the best practices, current events in the world of application and cloud security. If you're an AppSec professional, by the way, looking for an opportunity to work with some of the best, not to brag, but definitely to brag, in the industry, or if you're a developer with an interest in cybersecurity, please be sure to check out our careers page at forwardsecurity.com/careers. In fact, I think maybe in the future we should do an episode as to why we're looking for developers with an interest in cybersecurity and not just people who've been doing AppSec or security for a while.
Yes.
Because I think it bears some explanation. But also, we would greatly appreciate if you'd subscribe to the podcast wherever you listen to the show, and be sure to follow us on LinkedIn and Twitter, Forward Security. Links are in the show notes. So today, I think we're going to be starting from where we left off in the last episode. Last episode, we talked about the DevSecOps pipeline and the OWASP top 10 for DevSecOps. So most of us have, just as a little recap, a lot of us have heard of the OWASP top 10. Usually it's in reference to application security. And you hear things on that list like injections, like SQL injection and cross-site scripting and command injection and stuff like that. And what else? There's log mishandling and access control issues. Well, we have for under OWASP, there is a similar top 10, and it specifically covers the DevSecOps issues. In the last episode, we covered 1 through 5, and today we're going to cover 6 through 10.
You mean we're not going to talk about the Flipper Zero?
Oh,
this was going to be all about the Flipper Zero. We got to do an episode all about that. So.
Yeah. Once we dig in, we just got them. Farshad and I have just got these toys. Actually, mine's in the mail. It should be coming in a couple days, and I cannot wait to just walk around town. I imagine in my mind's eye, I'm just changing traffic signals and opening car doors and having bridges go up and down.
And we'll talk about them at the next episode.
Yeah. So I think, Iman, you would be a good person to start us off from where we left off.
Yeah, actually, we were talking about like top 10 CICD security risks, and we've covered the first 5 topics, and we've left off with insufficient credential hygiene. And, I've seen that a lot between our customers.
Is that when credentials don't wash their hands?
I mean, yeah, don't wash their feet, actually. The thing is that insufficient credential hygiene risks involve an attacker abilities to obtain and use secrets and tokens throughout the pipeline due to flaws in access control, insecure secret management, and also overly permissive credentials. And, major flaws affecting credential hygiene we can include like code containing credentials pushed to SCM repositories such as GitHub, insecure usage of credentials within build and deployment process, and like in CICD pipeline, and credentials in container image layers. Someone put like .em stuff inside their containers, Docker containers, and also credentials printed to console output. I've seen that, and also unrotated credentials. And this is a common flow. And go ahead, Jared.
Well, I was going to say, so what I'm understanding, I just want to summarize if I can, just to make sure I'm following. So it sounds like this issue, this number 6, is mainly about not keeping your credentials. Is this, first of all, well, okay, so it's not keeping your credentials anywhere that is hard-coded, not in your environment variables, or not in your container, not in your, environment variable wouldn't be hard-coded, but inside the Docker, I suppose you would have to hard-code to get it in there, maybe.
Yeah, the thing is that not hard code that in the exactly. Some people they hard code credentials inside the Docker image. This is not good actually. And if you want to recommend some stuff for improving credential hygienes, we should continuously map credentials and ensure they follow the principle of least privilege. We should avoid sharing the same credentials over multiple contexts, and we should prefer using temporary credentials and periodically rotate the static credentials.
Yeah.
Also, we should limit the credential usage to predetermined conditions, and also we should use those Git secrets in our pipelines. Like there are a bunch of them. I believe there was one by Truffle, and there are a bunch of tools that we can integrate in our pipeline. They find secrets based on different methods. Some of them they're using regular expressions. The other ones they're based on entropy, and they detect secrets. Farshad, go ahead.
I was going to say I attended an interesting OWASP talk the other day. The presenter was Julius, from one of the co-founders of Mergebase, and he talked about this whole Git secrets thing, right? What I had never thought about is that, when you commit something to Git, Git's almost like, in blockchain where it's immutable. Like it's just a journal of stuff that gets added, and it has all the versions, everything you previously sent there. You can't really delete things. So, the problem is when people commit secrets to the repository, that stuff goes in there permanently, right? And these secret removers, in order to remove the secrets, they have to rewrite your entire repository. So essentially the tools, what they're doing behind the scenes, they're copying everything locally, removing secrets, deleting that whole repo, pushing this thing up. I'm like, wow, I thought you could just go and run the scanner. It goes, oh, I found this one part of the code, I'm just going to delete that. No, you can't really delete it, because this is all committed in such a way that's like a journaling, like a journal almost, that you're, like a journaling file system where you're just building on top of it, and it's immutable. And for good reason, right? So yeah, so it's a difficult thing. So ideally you wouldn't commit them to begin with, but people do that. It's pretty common. So those tools often go and rebuild it and remove the stuff that way. But Jordan,
yeah, I was just going to say that. Yeah, so there are a couple tools that you can use. A few that I've heard of are this BFG repo cleaner that's actually recommended by GitHub, and then there's another tool called Git filter repo. So these are both open source tools, and they basically help you rewrite your history. You can delete files, and you can also replace text. So if there's any specific passwords in there, you can have it replace those, and it'll say deprecated password or something like that.
However, I will say, I just want to add to this discussion by saying, once you've discovered that you have secrets in your Git repo, deleting them isn't enough. You're getting rid of them from the history, but they've been exposed now. And now it's time to go and find out what those passwords were used for and rotate them to a new password. Good call out. Yeah, absolutely. Just clearing them out. If you haven't rotated it, there's already knowledge of it out there. Absolutely. One other point I want to add as well, I don't think this is listed in this OWASP, with respect to credential hygiene, but this section does talk about, credentials being used security. One of the other things is that how you pass them to your containers. If you are using containers, if you're using CICD, often, people have different ways of passing these things. The worst way to do it is you have the secrets in a config file, and then that gets loaded. That's hard coding the stuff, not so good. This should be dynamically pushed to the container. An okay way is using environment variables, but you have to also be cognizant, and really, in some situations that may not be appropriate, because environment variables, once they're pushed into that container, they're visible by all processes within that, also by the container runtime process below it. Mm-hmm. So someone could do a PS minus AX, and then they'll see all the processes running, and all the environment variables are possible to get them exposed. So for that reason, if you're running in an environment where your container is running with other people's containers, it's not a good idea to pass it that way. The better way to do it is through having the secrets in a credential store, like a Key Vault in Azure or KMS or something like that, and then using identity-based access, so that when your container wakes up, its identity will give it access to go and fetch the secrets, or maybe a wrapping key that can unwrap that config file. If you want to do it that way through the configuration or something, you can encrypt all the parameters in that config file, and then unwrap them once the container's up and running, and operating under an identity context, which allows it to go and access the credentials in the key vault. Yeah, I think that's a really good call. That's a really good call. I want to make a correction to something that I said earlier, which is that I called it the DevSecOps top 10. Now that I'm staring at it, it's the OWASP top 10 CICD security risks. So if you're going to be looking for this, following along, that's what it is. Now, I'm going to ask a stupid question. There's no such thing as a stupid question. Well, my question is, thank you. My question is, when right now, the credentials that we're talking about, are we talking about credentials that the application uses, that we have to, the application needs access to certain credentials, and we sometimes in the pipeline need to pass them to the application, sometimes for startup, sometimes even to be used during runtime? Or are we talking about credentials that are used to actually run the pipeline and the various things that the pipeline calls?
I think the context of this particular control is the credentials that the application uses to access resources once it's up and running. For example,
that's what I thought too.
Database credentials, keys for Twilio, et cetera, et cetera.
Okay.
But I don't think we should exclude other credentials. I think generally, any credential is important. So as a principal, developers should, people building applications should never hard code them, and they should take all the care that we've been talking about as a generality. But yeah, good.
Yeah. Yeah. So actually, that's true. When I look at description, I see code containing credentials being pushed to one of the branches. So this would be like hard coded secrets for your app, and then the other one is credentials used insecurely inside the build and deploy process. So I would imagine, if you're calling SonarQube or something and you need an API key for that. Yeah.
There's one other call out here. It says credentials printed to console output. A lot of people lose sight of it because when you're running your pipeline, what is happening? We've all built pipelines. Every step is something you execute, right? It could be a shell command or it could be something, right? So imagine you call a shell command and you pass it a parameter. That parameter is a credential. Guess what? That's going to go to the history, console output, all that stuff, right? So you got to be also really clear, very, very careful about what you're passing into your pipeline, because it could get logged into the console output or somewhere else.
Right.
Let me share my screen and show you an interesting thing about how the brew has been hacked, homebrew, I believe. And the thing is that, the guy wanted to hack the homebrew, and he first searched over the reports and HackerOne, and he found that there is a Jenkins, open Jenkins.
Oh.
And then he went through the open Jenkins logs, and he has seen some he has seen some environment variable, and then opened the environment variable, and GitHub API token was there. And
nice.
This is publicly accessible. One thing, and the guy was able to get a right access to their repo, and you can assume how things can get worse after this. Actually, many people are using Brew, and this is a simple thing, but I can bet there are many such incidents involved. You can check the HackerOne reports for that. Actually, awesome.
Very cool. Very cool.
Awesome. We can switch to the next one, and the next one is about insecure system configuration. Insecure system configuration risks arise from flaws in the security setting, configuration, and hardening of various systems across the CI/CD pipeline. And CI/CD environments are made up of multiple systems from different vendors, and their security setting and configuration have major influence on the overall security posture. And there are some examples of potential hardening flows: outdated systems or component lacking security patches, that is very dangerous, overly permissive network access control, self-hosted systems with administrative privilege, and insecure system configuration, inadequate credential hygienes. All of them are part of insecure system configuration. And Farshid, I want to know your opinion about this category.
Yeah, I'm looking at the recommendations. It's funny because the top recommendation they make in that section is maintaining an inventory of systems and versions in use, right? And we find that a lot of clients that we work with, that's where the problems begin. They don't have an inventory of the applications and the systems in use. That's a big problem. So it's really important to have that, and having a software inventory and making sure that you're always checking for vulnerabilities in your whatever you've got in your inventory. And if it's a patch available, you should patch it. The second one that they point out is that making sure network access to systems is aligned with the principle of least access. Jared and I were talking this morning about someone that wanted to know whether they should have containers be accessible so that they can go and change configuration and things like that, right? That's often, especially in modern day development, that's often not recommended. It's actually recommended in modern day architectures is to actually not have any access to the stuff once it gets deployed. So you should design your modern applications in such a way that they're immutable and ephemeral, so that you can just treat them like cattle and then they die and you can just replace them, rather than this thing that you maintain and you patch and all that kind of stuff. The advantage there is that if you don't have access, then neither do developers. And why should you go and SSH into that and patch it? Why not just deploy a new container and just build it from the latest versions of the pieces that build that service for you? So yeah. Anyway, Jordan, what are your thoughts on this topic?
Yeah, I mean, I think this one can be pretty serious, especially because it's important to note that some of these SCM and pipeline tools like Jenkins, they can be self-hosted, right? So you can have something like Jenkins or GitLab, which you're running on a VM in the cloud or wherever on like a Mac Mini. I know with Jenkins, I don't know if this is still a thing, but when I was working with Jenkins, they actually had an input called like command or something, and you could literally run whatever you wanted for that. So it was basically like, it was like RCE, but it was built in. It was a feature as part of Jenkins.
It's got to execute scripts, right? It's got to do that.
Absolutely.
That's its functionality.
Absolutely, right?
Was that on by default, or did you have to configure that, or?
It's on by default. It's like it's like for an admin. But the thing is, like where I was, in previous places I've seen, a lot of people just have administrative privileges, just like anything else. So when it talks about like a self-hosted system that has administrative permissions, you got to be careful about those permissions, who you're granting them to, because you could have an insider take over that entire system that way. And I mean, if an outsider gets compromised credentials, same kind of thing. So yeah, I think this one's really important.
Right.
Yeah.
Okay. So basically, harden your systems, right? Be doing regular configuration scans, scanning for patches, having antivirus systems, ensuring that password access is turned off if for some reason there's a system that requires SSH.
And a common it says here also, what important to note is a common misconfiguration is around giving debug permissions on execution nodes to engineers. I think, Jordan, that goes along the lines of what you're saying, right? So, it says it's common practice in a lot of places, but it's really imperative to make that into consideration, that, you should follow the principle of least privilege and not get everybody that debug permission.
Absolutely. Yeah.
Yeah. And, we can use CIS benchmarking tools to harden our, I don't know, for example, operating system, anything that is related to CIC pipeline. I believe there should be a CIC benchmark for that. And there are some tools like CICD CIS evaluator, benchmark evaluator. We can use that. And also we can talk about the next category, which is ungoverned usage of third-party services. And the CICD attack surface compromises an organization, organic assets, and third-party services, which can easily be granted access to resources, expanding the attack surfaces. And we are talking about third-party integration with the CIC pipeline. There are various methods such as GitHub application, and we allow them to connect with different levels of permissions. And that could be dangerous, and those third parties can kind of propose some risk to our CI/CD environment. I want to know your opinion, folks.
Especially if your app would fall under what ASVS would consider a level 3. So you need to make sure that you're using hardware security modules and that your apps exists in a separate memory space from other apps. This is especially important because we leverage tools like SonarQube and Veracode and things that are, Veracode doesn't call itself a cloud service, but in a sense it is. Many of these commercial SaaS grade products are, you send your code out somewhere and it's part of your pipeline. Your pipeline goes, okay, we're going to do a SaaS scan, and if it's not SemGrep or something that runs as a local agent, it sends your source code somewhere, and then you get a report back. And it's important to know that these are third-party services, and this is where supply chain attacks come from. Your source code is now visible to these systems, and that's not even taking into account some of the other third-party services you might be using. If you're using Datadog, I mean, I shouldn't name it. Just anything where you're sending logs out of your pipeline, even where your agent itself runs, or if you're using Jenkins in the cloud. Anytime you're using something that isn't owned by you, it's important to it's important to weigh the pros and cons of using a third-party service and consider what kinds of, how vetted are their security processes.
Yeah. And the other thing is the access control, right? Because you guys all seen this when sometimes you're like, hey, I want to use this third party, and then it uses say OAuth, right? And it says, oh, this wants to access to this, and all these things, right? They ask for access to a whole bunch of things, and a lot of people don't give that any thought. They just click yes, you consent, and you give it permission to act on your behalf and do all these things. Is it necessary, right? So one of the things OWASP recommends is that make sure that you look at the method of integration, and you look at you have controls and procedures to maintain visibility over the level of permission that is granted to those third parties and level of permission actually used by them, right? So those are things that most people don't even think about, but it's really important to inventory it and then look at what you're giving them, what they're using, and making sure that you're following that principle of least privilege.
Mm-hmm. Just to keep the momentum going, I think we've covered this. I'm not sure what should we recommend in this case. For me, the recommendation is make sure that you vet well any third-party systems that you integrate with. This is not even to mention third-party libraries, which I think are more difficult to vet.
Yeah, and don't just click authorize, like when
read the scopes.
Working with one of these third parties and you're doing that OAuth flow, and it says, do you want to authorize access to GitHub to do these actions? Like actually look at what the actions are and review them. As far as it says, inventory them, make a note of that.
Right. And maybe to review periodically.
There's a thing that they call out here too. It says the build process should run inside a scoped context with limited access to secrets and code, right? Because like if this is a third party integration and it has access to all your secrets and all that stuff, that might not be so good. And that comes into fine tuning. Let's say, for example, you're in Kubernetes, and have you set up namespaces with the right policies? How much segregation are you doing? This all goes into like really looking and segregating your architecture, right? And thought should be going into that. And then the last point here too is that a lot of people, when they deprovision, they don't really look at all the third parties that they're no longer using, right? So it's really important to do that review and look at what you're not using and remove things that are
exactly. I believe like recommendation, exactly as you told guys, it should include implementing governance control in approval, integration, and visibility over ongoing usage. Also, we should have like the provisioning stages of the third-party usage lifecycle. And yeah, that's it. I believe we can wrap it up here and we can go to the next item, which is improper artifact integrity validation. And improper artifact integrity validation risks occur when there are insufficient mechanism to validate code and artifacts in CICD process. And this can allow attackers to push malicious codes or artifacts down the pipeline. And this impact, the impact is that adversaries can exploit this to execute malicious code on CI/CD system, and worse than that, in production. To prevent such risk, actually, we should have like the integrity validation, such as code signing, artifact verification, software and configuration drift detection.
So I don't know how much time. Can I throw a challenge to us here? So code signing, that's one of those things that it's always recommended, but I'm curious to hear everyone's view here. A lot of times when I talk to developers, they're like, well, what are you talking about? First of all, it only, from what I remember, code signing is available for Java. Like we use that as the bank. We signed all of our Java artifacts, but you also have to make sure that the server is also validating the signatures, right? And I think it's available for .NET as well. But when it comes to other things, when it comes to other are we like say JavaScript? I mean, is there code signing for that? Like what are the solutions that are available to people out there? What have you all seen?
I think it kind of depends by what we mean by code signing. Like I'm just reading that section. It says SCM solutions provide the ability to sign commits, right? And so GitHub, I think this is sort of a default thing, is when you set up your private keys or whatever, and you're pushing to your GitHub repo, usually you'll see like a little green check mark beside your commit. And that's actually like it's showing that commit was signed and it was actually produced by you. And I think there's a way to circumvent that and not actually sign the commit. So if that's what we're talking about, that sort of thing is sort of built into GitHub. And I think it's probably, built into these other SCM platforms.
I'm looking at the second recommendation there. It says artifact verification software. Usage of tools for signing and verification of code and artifacts provide a way to prevent unverified software from being delivered down the pipeline. So they're talking about the delivery. I guess what I was talking about earlier was running signed code, right? Like I know that certain architectures support it to that you can run unsigned artifacts, but I was just curious to see if that is available outside of Java world.
For JavaScript, actually, especially on the Electron desktop application, they use JavaScript, and there is a feature that you can sign your JavaScript code. Also, like,
so how does it work on the runtime then? Because then I guess like when you're running it on, let's say, on some server, right? Like let's say this is a node,
it's a node. If you inject something, it's not going to execute that actually.
Oh, so it'll only execute things that are signed, and where is that enforcement happening? So on the runtime, I guess that
in the runtime.
Interesting. I'd like to learn more about that. Yeah, we can maybe have an episode. That's a topic that I think is not well understood and not well implemented. If people knew and implemented it well, I think it would prevent a lot of issues.
Also, like for browser extensions, they're written by JavaScript, like Google Chrome. You can sign them actually.
Yeah, good call.
Yeah. And also, there is a header, HTTP header called content-signature that sometimes I've seen that they use that for signing like the backend JS code actually.
Ah.
Yeah, but for example, SRI is not signing, but kind of computing the hash and checking the hash against like some JavaScript on the CDN. And
it's like more of an integrity check.
Yeah, that is kind of an integrity check, which kind of similar to this concept. But yeah, that's it actually.
So, Jared, what are your thoughts on this? Have you dealt with signing?
I haven't dealt with it in the pipeline, so I was interested to hear what you guys were saying about it. I mean, my developer brain says I would write something that would compute the hash of these objects and then send those hashes to a different place than the build artifacts go. Because if I can affect the build artifacts, then I can probably affect the checksums that I put there.
Oh, right.
So I create some checksums using something a bit stronger than MD5. Maybe take SHA-2s of these of my build artifacts and send those somewhere else, and then send my build artifacts to Artifactory or JFrog or wherever, and then compute the hashes separately and see if the hashes match what I sent externally. Now that's just me thinking about how I would build a solution. I don't know. I mean, maybe there's a more simple way to do it, but
this is not all about like even the artifacts that we are using. Like we had that attack called like dependency confusion attack. If the developer was checking the signature, we wouldn't be vulnerable because like that package or that npm package that is injected is coming from other place with different hash actually. Actually, let's go for the last item, which is insufficient logging and visibility.
The bane of my existence, the thing that not a lot of companies do properly.
Go ahead, Fashion.
No, I mean, I don't. Go ahead. You can talk about it. I'm just saying that a lot of companies we deal with don't have this right. Big and small. Big and small. It's not like, oh, small companies aren't doing it. I've worked with large companies. When it comes to application logging and monitoring and visibility and CICD, they're not doing the application one, let alone even the pipelines that are building it. I think that's a huge problem.
Yeah, I've seen some chat shows that, for example, there was a SonarQube 20 with 20 admins and developers. When they found bug, they went straight to the SonarQube and disabled the rules. And after that, there were no logs. Who has disabled this rule, this SQL injection rule? And I've seen those situations. But, insufficient logging and visibility risk in CICD environment can allow adversaries to carry out malicious activities undetected, which is kind of dangerous. I believe we should have like a centralized location, such as SIEM for all the logs that supports aggregation and correlation of the logs. And between different systems, because we have different systems, we should have a mechanism to correlate and aggregate.
But why is logging? I want to ask the team here. Why is logging and monitoring important in the first place?
If you want to have visibility into what's going on into your system, I mean, that's just logging. But monitoring, you want to reduce the amount of persistence that an attacker can have, or even prevent them from getting in the first place. If you can monitor for the right things, then you can look for anomalous requests before an actual successful payload is delivered.
Bingo, Jared. You said if you're monitoring for the right thing, right? That bingo, the right thing is it. Because so a lot of companies don't do any logging monitoring. The ones that they log stuff and they monitor, they're monitoring all these things. It's not the right thing, and then they get a lot of noise. So what the system should do is they should do a threat model exercise, and based on the threat model, you should determine what are the detective controls needed to detect those threat scenarios, and only monitor those medium and high risk threat scenarios, so that if you're not just blindly logging a whole bunch of stuff. If a lot of these SIM solutions or things that people just turn them on and have all these alerts that are generic, and then they just produce a lot of rules that are generic, and they produce a lot of alerts. So it's important to monitor the right thing. I like what you said there, Jared.
Yeah. Okay, I think I want to try to get through the rest of these if we can. So what we talked about? So logging visibility.
Yeah,
so I think actually this is the last one here, logging visibility. I didn't realize that. Great. Yeah. Well, never mind. Forget that I said anything. Okay. Good work, everybody.
Awesome. I just want to say also centralization is really important, right? So if you log and monitor, the right thing is important, but also centrally logging them. Because again, another thing that I've seen at really large companies is they do AppSec logging, but they're logging them locally. And then I'm like, what happens to it? They're like, I don't know, it just lasts for 90 days on that VM and then it's gone. I'm like, oh, two problems there. Is gone after 90 days. Second is that if a attacker compromises that machine, they can delete all the logs, right? So you want to make sure that they're central. And then particularly for CICD as well, you need, like as Aman was saying, you want to know did someone disable stuff? Are you identifying the appropriate things, and then are you formulating what you're logging based on the attacks that are applicable to your CI/CD environment?
Yeah. And logging in general is good when we have an incident, either by an insider, a malicious insider, or outsider, and we can track what happened and how they have breached the system actually, and what are the consequences. And that concludes this episode of AppSec Insiders Podcast. And we hope you've enjoyed learning about attacks on CI/CD pipeline. This was our second episode on this topic. Remember to tune in next time as we delve deeper into the role of application and cloud security and explore new ways to protect our digital assets. Also, we have 2 events that are upcoming. The first one is OWASP Pacific Northwest on June 10th.
I'm speaking at that also, one, and Forward Security is also a proud sponsor. This is the first year of this conference taking place in person. The idea came during COVID. We've ran it 2 years virtually, and this year we're going to visit the beautiful city of Portland in Pacific Northwest. And the idea is that we'll rotate this event in the Pacific Northwest so that people can come and enjoy the beauty that we have out here. So next year we'll be in Vancouver, then we'll do it in Victoria and Seattle. So please join us. It's a wonderful place in the Pacific Northwest, and we're going to talk about a lot of really cool AppSec topics, and I'll be presenting as well.
Awesome. Also, we have Collision on June 26 to June 29. And that's it. And we appreciate your support.
And just one other thing, at Collision, Forward Security is going to have a booth. So come and talk to us. Yeah, we're going to be showcasing our Eureka product. If you want to come check out a demo or talk to a bunch of us, we'll be there at Collision. We'll have a booth. I don't know the booth information yet, but we'll tell you later.
That's good. That's good. We appreciate your support and engagement. If you have any topics in your mind, please don't hesitate to reach us out. And our email is appsecinsiders@forwardsecurity.com, or we have the Twitter handle of FWD_SEC on Twitter, or feel free to follow Forward Security on LinkedIn for the latest news in application security and other job opportunities. And also, please consider subscribing to our podcast. And have a good one. I want to pass the mic to Farshad, Jordan, and Jared to say goodbye. Go ahead.
That was a wonderful conversation. Thanks for having me.
Likewise, thanks.
Yeah, thanks everyone for joining. See you next time.
See you next time. Have a great day.
See you next time.
Bye.
Have a good one. Bye.